Bridges are more than just structures of steel and concrete. They are lifelines that connect communities, cultures, and economies together. They stand as powerful symbols of human ingenuity, enabling us to overcome geographical barriers and facilitating trade, communication, and progress. From the ancient Romans who built bridges to expand their empire to the modern engineers who design awe-inspiring structures that defy gravity, bridge building has always been a testament to our collective ambition and ability to connect our world. Imagine a world without bridges. Transportation would be severely crippled, journeys would be longer and more arduous, the exchange of goods and ideas would slow to a trickle. Bridges are the arteries of our modern world, ensuring the smooth flow of people, products, and information that are essential for our interconnected society. Whether it's the iconic Golden Gate Bridge in San Francisco or the humble footbridge connecting two villages across a stream, each bridge plays a crucial role in shaping our world. They are not mere structures, but testaments to human collaboration, innovation, and the enduring spirit of connection. The history of bridge building is as old as civilization itself, stretching back thousands of years to when early humans first sought ways to traverse the natural obstacles that divided their world. Early humans, faced with the challenge of crossing rivers and ravines, devised ingenious solutions using natural materials like fallen logs and woven vines. These primitive bridges were simple yet effective, allowing communities to connect and thrive. As societies advanced, so did their bridge building techniques. The evolution of bridge design reflects the growth of human knowledge and the desire to overcome greater challenges. The ancient Romans, renowned for their engineering prowess, mastered the art of arch bridges, constructing enduring structures like the Pont de Gard in France, which still stands today as a testament to their skill. These bridges were not only functional, but also architectural masterpieces. These arch bridges, made from stone and held together by the force of gravity, were a marvel of their time, demonstrating the potential of human ingenuity. The precision and craftsmanship involved in their construction were unparalleled. The Middle Ages saw the emergence of magnificent stone arch bridges, like the Charles Bridge in Prague, adorned with statues and serving as both a vital transportation route and a symbol of the city's identity. These bridges became landmarks celebrated for their beauty and utility. With each passing era, bridge design and construction techniques evolved, incorporating new materials and architectural styles. The transition from stone to iron and steel marked significant milestones in engineering history. The Industrial Revolution ushered in a new age of bridge building, with iron and then steel replacing stone as the primary building materials. This shift allowed for the creation of stronger, more durable bridges that could span greater distances. This period saw the rise of suspension bridges, like the Brooklyn Bridge in New York City, which used steel cables strung between towering towers to support the bridge deck, allowing for the construction of longer and more elegant spans. These bridges not only connected places, but also became symbols of human achievement and progress. Just as there are different tools for different jobs, each designed to perform a specific function with precision and efficiency, there are different types of bridges designed to suit various geographical and structural requirements, each tailored to meet the unique challenges of its environment. Each type has its own unique characteristics, advantages, and construction methods, making them suitable for specific applications and conditions. Suspension bridges, known for their elegant designs and long spans, these bridges are engineering marvels. Suspension bridges, like the iconic Golden Gate Bridge, use massive cables strung between towering structures to support the bridge deck, allowing them to span great distances. These bridges are ideal for spanning wide rivers and straits where intermediate supports are not feasible, providing both functionality and beauty. Cable-stayed bridges, similar to suspension bridges but using shorter, more angled cables directly connecting the bridge deck to the towers, these bridges offer a modern and efficient design. Cable-stayed bridges are often seen in contemporary architecture, providing a sleek and innovative solution to bridge construction. The Millau Viaduct in France is a stunning example of this type, showcasing the elegance and strength of cable-stayed design. Truss bridges. These bridges utilize a framework of interconnected triangles to distribute weight and resist bending, making them incredibly strong and stable. Truss bridges are often used for railroad bridges and can be constructed from various materials, including steel and wood, offering versatility in design and application. Arch bridges. Utilizing the inherent strength of an arch shape to distribute weight outward to the abutments, these bridges have stood the test of time. Arch bridges have been built for centuries, with the ancient Romans perfecting this design, and they continue to be used in modern construction for their durability and aesthetic appeal. They are known for their durability and aesthetic appeal, often becoming landmarks and tourist attractions. Beam bridges. The simplest and most common type of bridge, beam bridges consist of a horizontal beam supported by piers or abutments. Beam bridges are suitable for shorter spans and are often used for highway overpasses and pedestrian walkways, providing a straightforward and cost-effective solution. They are essential in everyday infrastructure, ensuring safe and reliable passage over obstacles, and are a testament to the simplicity and effectiveness of basic engineering principles. The construction of a bridge is a complex and fascinating process, requiring meticulous planning, precise calculations, and the coordinated efforts of skilled engineers, architects, and construction workers. Each step in the process is crucial, from the initial design phase to the final inspection, ensuring that the bridge is safe, functional, and aesthetically pleasing. It's a testament to human ingenuity and the power of collaboration. The seamless integration of various disciplines and expertise is what makes bridge construction a true symphony of engineering. Building a suspension bridge, for example, involves constructing massive towers, anchoring them firmly into the ground or bedrock, and then carefully stringing the main cables. These towers must be incredibly strong and stable, as they bear the weight of the entire bridge. These main cables are then used to suspend vertical suspender cables that attach to the bridge deck, distributing the weight evenly. This intricate web of cables ensures that the bridge can support heavy loads and withstand various environmental stresses. Cable-stayed bridges, with their shorter, more angled cables, require precise tensioning to ensure the stability of the bridge. The tension in each cable must be carefully calibrated to maintain the structural integrity of the bridge. Each cable plays a critical role in supporting the deck and must be carefully adjusted during construction. This meticulous process ensures that the bridge remains balanced and secure. Truss bridges, with their intricate network of triangles, are often assembled on-site, piece by piece, using cranes and other heavy machinery. The triangular design provides immense strength and stability, making truss bridges ideal for spanning long distances. The construction of arch bridges involves building temporary supports called centering to hold the arch stones or segments in place until the keystone, the final piece at the top of the arch, is placed, locking the structure into place. This method has been used for centuries and remains a reliable technique for building durable bridges. Beam bridges, the simplest type, are typically constructed by placing prefabricated beams across piers or abutments. Despite their simplicity, they are incredibly effective and can be built quickly and efficiently. Regardless of the type, bridge building is a testament to human ingenuity and our ability to overcome engineering challenges to connect our world. Each bridge stands as a monument to the creativity, skill, and determination of the people who built it, linking communities and facilitating progress.